Now let's move on to question number 3. Tartaric acid is the white powdery substance that coats sour candies such as Sour Patch Kids. Oh, that's cool. The combustion analysis of a 12.01 gram sample of tartaric acid, which contains only carbon, hydrogen, and oxygen, produced 14.08 grams of CO2 and 4.32 grams of H2O. Find the empirical formula for tartaric acid. Okay, so this is one of those multi-step questions. So first I'm just going to write down the mass of tartaric acid that we started with. This is given in the question. It was only like 12.01 grams. And first I'm going to calculate how many grams of carbon was released after the combustion analysis. So basically, to find the mass of the carbon, let me write it as step 1. We know that the mass of CO2 is 14.08 grams. I'm going to write out clear units so that you can see where everything came from and also how it cancels out in the end. First thing I'm going to do is find the moles of CO2 that was released. So to do that, it's just mass over molar mass. So the mass was 14. The molar mass of CO2 is 44 grams per mole. Then I'll also just put CO2 there. So we then get a number of moles of 0.32 moles of CO2. But now I'm interested in finding out how many moles of carbon is in that many moles of the CO2. So if you look at the formula for CO2, you'll see that only 1 mole of carbon is in 1 mole of CO2. So you'll see that these units will cancel out. And then to find the grams, basically I'm also going to multiply my moles by the molar mass of carbon, which is 12 grams per mole. And this is the molar mass of carbon. So if we were to do all of the math, you'll see the moles of carbon cancel out as well. And then we're left with a value of 3.84 grams of carbon. So now let's do the same thing for hydrogen. So 4.32 grams of water was produced after the combustion. And the molar mass of water is 18 grams per mole. So now I'm going to find the number of moles of water just by dividing those two values. And you get 0.24 moles of H2O. And then to find out the moles of hydrogen, there are 2 moles of hydrogen for every 1 mole of water, because it's H2O. And then also multiplying by the molar mass of hydrogen, which is basically 1 gram per mole. we end up with 0.4848 grams of hydrogen. So now, just by doing the law of conservation of mass, if I know that we had a total of 12.01 grams of tartaric acid, I'm going to subtract the 3.84 grams of carbon that was there. I'm going to subtract the 0.4848 grams of hydrogen that was there. And then we find out that 7.69 grams of oxygen makes up that tartaric acid. So for step 4, I'm now going to find the moles of the atoms. It's kind of like one of those multi-step, like redundant questions. But basically, I'll just do the 3.84 grams of carbon divided by its molar mass, which is 12 grams per mole. So we have 0.32 moles of carbon. Then let's do the same thing for hydrogen. 0.4848 grams of hydrogen divided by its molar mass, which is 1.01 grams per mole. And we get 0.48 moles of hydrogen. And then we do the same thing for oxygen. 7.69 grams divided by the molar mass of oxygen is 16 grams per mole. And we get 0.48 moles of oxygen. Okay, so for this last step, I'm going to try to write out this empirical formula just by using the mole values that we got. So for carbon, it was 0.32. For hydrogen, it was 0.48. And then for oxygen, it was also 0.48. So I want to try to get these values not in the decimal form. So the first step I'm going to do is to divide everything by the lowest value, which is 0.32. And then we get C1, H 1.5, and also O 1.5. But again, I don't want these in decimals, so I'm now just going to multiply it out by 2, just so that we can get whole numbers. So it's now C2, H3, O3 is empirical formula. Okay, so let's check out the answer from our junior tutor. They got all the grams of carbon, hydrogen, and oxygen. They got the moles, 0.32, 0.48, 0.48. They divided each by 0.32 and then multiplied by 2 to get C2H3O3. So this solution is correct.